Hey there and welcome. Today we're going to pull back the curtain on how these massive, complex databases are actually designed. See, before anyone writes a single line of code, they create a visual blueprint. And we're going to walk through exactly how that's done using something called the entity relationship model.
I mean, really think about it for a second. Every time you book a flight, like a post, or sign up for a class online, you're tapping into a super organized database. The secret to making all of that work so smoothly, without data just vanishing or getting mixed up, is having an incredibly solid plan right from the start.
So, here's our game plan for this explainer. We're going to start with the big idea of the blueprint itself. Then, we'll break down the individual building blocks, see how they all connect, touch on some more advanced features, and finally, learn how that blueprint gets turned into a real, buildable database. All right, let's jump right in.
Okay, so our first section is all about that master plan. Before programmers even think about coding, designers need a map that everyone on the team can actually understand. And for databases, that map is the Entity Relationship Model, or ER model for short.
The ER model, which was first thought up by Peter Chen way back in 1976, is really just a high-level way of looking at data. And the most important thing to get here is that it's a visual diagram. It's not code. It's a drawing, like an architect's blueprint, that lays out the whole structure before anyone gets lost in the nitty-gritty technical details.
So why even bother with the step? Well, because it's simple and incredibly powerful. It's a communication tool that even your boss, the non-technical person, can look at and understand. It forces you to think about the main objects, we call them entities, and how they relate to each other, totally separate from how you're going to build it. It's all about planning first, coding second.
All right, let's move on to our second section and see what pieces we actually get to draw on this blueprint. It all starts with two basic components, the main things we're tracking and the details that describe them.
First up, we have the entity. The easiest way to think of an entity is like a noun. It's the main thing we want to store info about. It could be something physical, like a car, or something more abstract, like a university course. And on our diagram, we draw every entity inside a simple rectangle.
Now, an entity by itself isn't all that useful, right? We need details, and that's where attributes come in. If an entity is our noun, then attributes are the adjectives that describe it. For our student entity, attributes would be things like their name, their age, or their student ID number, and we draw these as ovals connected to our entity rectangle.
Okay, now this is where it gets really interesting, because we have special symbols for different kinds of details. A key attribute, like a unique student ID that no one else has, gets underlined. A composite attribute, like address, can be broken down into smaller parts, like street, city, and state. A multi-valued attribute, which you see with that double oval, can hold more than one value. Think of someone having multiple phone numbers. And finally, a derived attribute with the dashed oval isn't actually stored. It's calculated from something else. Like, why store an age when you can just figure it out from a date of birth? These little symbols give our blueprint amazing precision. Okay, so we've got our nouns and we've got our adjectives. Now it's time to start forming some sentences. Let's get into our third section and see how we actually connect these pieces to build something meaningful.
The connection between our entities is called a relationship. This is the verb in our sentence. A student is enrolled in a course. That is enrolled in part, that's the relationship. And we show it on the diagram with a diamond shape. This is literally how we map out how different parts of our database talk to each other.
So the degree of a relationship, that sounds complicated, but it just tells us how many different types of entities are in the connection. A unary relationship is just when an entity relates to itself, like an employee who also manages another employee. But the one you'll see all the time is binary, which connects two different entities, just like our student and course example. Now, this next part is critical. We have to define the rules of the connection. We call this cardinality. The simplest rule is one-to-one. It means exactly what it sounds like. One of these is linked to exactly one of those. A person can have only one passport, and that one passport belongs to only that one person. Simple.
A much more common rule is one-to-many. This is where one entity can be connected to, well, many others. Think about it like a single teacher who teaches a whole classroom full of students. One teacher, many students. You see this pattern everywhere.
And many-to-one is really just the flip side of that. It's just a matter of perspective. From the student's point of view, many different students can all be enrolled in the exact same course. So many students, one course. And finally, we have the most flexible type, many-to-many. Here, a student can enroll in a bunch of different courses, and at the same time, a single course can have a bunch of different students in it. Getting these rules, the cardinality, right is probably one of the most important jobs of a database designer. It makes sure the whole system is logical and reliable.
All right, with the basics down, let's level up and explore a few advanced concepts. Because, real-world systems can get messy, and our blueprint needs the right tools to handle that complexity.
So sometimes an entity just can't exist all by itself. We call this a weak entity. A classic example is an employee's dependence. A dependence record only makes sense if it's tied to an employee, right? If that employee leaves the company, that dependence data isn't really relevant anymore. We show this special dependent relationship on our blueprint by using a double rectangle.
As apps got way more complex over time, the basic ER model needed a bit of an upgrade. So the Enhanced ER Model, or EER, was born. It basically brought in some more powerful, modern concepts to handle these new challenges.
The ERER model gives us some really cool techniques. For instance, specialization is a top-down approach. You take a general idea like vehicle and you break it down into more specific types like car or truck. Generalization is the total opposite. It's bottom-up. You might look at an employee and a student and combine them into a more general person entity. These techniques just let designers build much smarter and more efficient models. And now for the final and maybe the most crucial step. We have this beautiful logical drawing, but how do we turn it into something a computer can actually use? This is where we translate that blueprint into a real construction plan. The key thing to remember here is that converting the blueprint isn't just guesswork. It's a very systematic process with clear rules. For example, Rule 1, every strong entity becomes its own table. Simple. But check out Rule 3. A many-to-many relationship also requires a brand new table just to link the other two. And then look at the one-to-many rule. We don't need a new table for that. Instead, we just take the unique ID from the one side and add it as a column in the many sides table. Following these strict rules ensures that our logical design gets translated perfectly into a physical database.
So we've gone all the way from a high-level idea to a concrete set of rules for construction. You now have the fundamental knowledge of how database architects design the very systems we all use every single day. So thinking like a designer, what's the first system you'd want to map out?